what is this van der Waals forces and everything, right? Now in the states of matter, first of all, we'll see there are generally three states are there. We know that one. What are the three states generally we are having?
Solid,
Solid,
liquid,
liquid, and
gas.
gas.
Solid, okay, liquid, and what happened? Gas phase. Three phases are there. Above the gas phase is called what? Anybody knows?
Bose-Einstein.
Bose-Einstein. Sorry, not a Bose. Just a minute. Plasma state. Sorry. Above the gaseous phase is called what? Plasma state. And below solid state is called what? Bose-Einstein. Here Bose means what happened? Sachindranath Bose. Okay? And it is below the, that means if you cool solid will convert into Bose-Einstein state. If you heat gas will convert into plasma state. Generally, this plasma state will be absorbed in the form of gases in ionic nature. For example, nitrogen is there. It's a gas. Convert this one into nitrogen ions like this. This is called what? Plasma state. This will exist in what happened in the sun, stars, isn't it? Because of the combustion, what happened? They exist in the form of plasma nature. But these two we are not having in the syllabus. Leave it this way. Now, whenever if you heat solid, what happened? We get the liquid. Liquid, you heat what happened in gas. That will discuss everything in detail. Now, let me first of all discuss about intermolecular forces. What are the forces which operates between the molecules? Intermolecular forces, isn't it? That may be attractive and that may be repulsive also. Okay, they may be attraction, they may be attractive forces, they may be repulsive forces also operate. Now, where they operate? Between the atoms and molecules, right? So don't, this is not, you're not considering electrostatic forces here. Don't take electrostatic, that means ionic forces here. I will develop that one in the next examples, right? Now let me see what happened. First thing, van der Waals forces. Van der Waals forces. Attractive intermolecular forces generally will take what actually? Van der Waals forces. For example, I am writing here methane. I am writing. For understanding, I have taken what? Methane. Now on methane, we cannot have any charges generally. But methane will have some type of attractive forces. Between methane and methane, you are having some type of force are operating between these two. Okay, that forces maybe we can call van der Waals forces. Okay, now in that van der Waals forces, we'll discuss dispersion forces or London forces. First thing we'll discuss about this one. London forces or dispersion forces. Now generally London force or dispersion forces are operating between the non-polar molecules. What? You underline in your textbook, non-polar molecules. Otherwise write down in your notebook. All of you write down your notebook. Dispersion forces will operate in non-polar molecules only. Right? Now what is non-polar molecule? Which cannot develop any negative and positive charges, which could not exhibit what happened, negative and positive charges. For example, A and A is there. I cannot write a negative and positive between because both are what having same electronegativity. You could not place anything. For example, hydrogen. Can you write negative and positive charge between these two? We have discussed in dipole moment beta and chemical bonding. We discussed this one, polar and non. If you have any doubts regarding polar, non-polar, you again watch dipole moment video. You will get everything there. Watch dipole moment in chemical bonding, your doubts will be clarified. Hydrogen, you cannot develop any positive and negative charge here. So this is non-polar here. It is a non-polar here. Carbon dioxide is also non-polar because of what actually? Mu is equal to 0 because of I told you net dipole moment will be 0. You can take that one also what? Non-polar. I told you this one because of dipole moment. Iodine is what? Non-polar here. Because we could not develop any charges over here. For example, to attraction forces, when they operate attraction forces, when you get any attractions between positive and negative, then only we get attractive forces. Now, in this case, what is happening? Let me see better. This is important for you. Please listen here carefully. This atom A, this one is atom B. Atom A, atom B. Now, this is not nucleus beta. It is not nucleus. It is not at all what happened. Electrons here. Simply I have taken a positive charge and remaining blue color is what? Negative charge. The center part is positive. Remaining you take as a negative part. Remaining part you take as a negative part. Now, this is symmetrical one. See, symmetrical. The negative part is uniformly distributed. It is uniformly distributed here. See, the positive and negative is uniformly distributed, like symmetrical it is. Now, because of something, after something, whenever A and B, both these two, A and B, both are what happened? Meeting with each other. They're coming near to each other. In that case, what happened? The electron cloud, the negative cloud and positive cloud, they are moving aside like this. You see, the negative cloud, this is the negative part. The negative part is shifting like this and positive is shifting like this. Now, because of this, what happened? You see, negative part and positive part. Now, they will definitely get what type of forces here? Attractive forces. Okay. Now, what actually instantaneously, when it is developed, what happened? In atom B also will get the dipole actually. Now, we are getting dipoles. See, positive, negative poles. Here also positive, negative is there, but negative, negative. It is a negative and it is a negative here. Negative, negative. We don't have any attraction forces over there here. But once they symmetrical, we don't have any attraction force. Now they are becoming unsymmetrical now. Now they are becoming unsymmetrical. So atom A with instantaneous. Instantaneous means what happened? When it comes, when atom B reaches A within that time only, within the short time only, when atom B reaches atom A, instantaneously the dipole more electron density on the right hand side. The electron density is moving very here. Negative is nothing but density, electron density. This negative means nothing but electron density. I'm calling. Moving right side like this. Now in atom B also induced dipole here. Here also what happened? Positive, negative is induced here. Dipole is nothing but negative and positive. Now between these two, what type of force are operating now between these two? Because it's a positive, this is what electron cloud, negative. Now between these two, what happened here? Dispersion forces and London forces are operating. Okay. Now when you get this dispersion forces, London forces beta, when you have what? Non-polar molecules. Whenever what happened? Non. In this case, the poles are, isn't it, instantaneously developed. Instantaneously developed and they're induced also. Understood beta? Dispersion forces, London forces? Everyone understood here?
Yes, sir.
Yes, sir.
Right. Now this one is a temporary only. Why? Because when B comes here only it will develop. If B not comes, what happened? Nothing will happen. So here the attraction forces between these two is a temporary forces only better. It's only temporary force only. Temporary dipoles will exist. Now this is the ratio relation beta. The attractions, interactions which are present is inversely proportional to the radius. That means what happened? The dispersion forces or London forces, what happened? The inversely proportional to the, why? Because higher they having distance, what happened? Forces will be less. No. For example, A and B, they are away from each other. In that case, attractive forces will be less here. When A and B are near to each other, what happened? Attractive forces will be strong here. That is the reason we can take this one. 1 by r to the power of 6. The dispersion forces which are what? Inversely proportional to what? R to the power of 6. R to the power. R is nothing but distance between the two particles. This one. This is the R actually. Distance between the two particles. This distance. Isn't it? Next we'll move to what here? Dipole-dipole forces. Dipole-dipole forces. Dipole-dipole forces will operate between polar molecules. Because in polar, what is the meaning of polar molecules? They are negative charge and positive charges. Polar molecule is nothing but what? Negative charge and Already they developed. No need to induce that one. So already they are having. So permanent they are actually. They are permanent. So charges are already is there. Partial charges when you get beta, when it is covalent bond. A charge is called partial charge when the bond is what? Covalent bond. If it is ionic bond, you can call complete charge there. Now I have taken an example called HCl. HCl can form a covalent bond. It can form a covalent bond, one electron from here, one electron from here. Now definitely because of more electronegativity, chlorine is having negative character, hydrogen is having positive character. So definitely it is a polar molecule. Now what type of force is operating here? Dipole-dipole interaction. You see? Dipole-dipole interactions. This part is. Now let me see this one, dipole-dipole interactions you observe. Hydrogen, I have taken one molecule. Now I am taking two molecules. Now between positive, negative is there, positive is there. Now between these two, what happened? Attractive forces are operating. So this is nothing but called dipole-dipole interactions between the hydrogen chloride molecule. Dipole-dipole interactions. See? Dipole-dipole interactions. So this is forming where? In dipole. Here it will be 1 by r cube. There 1 by r to the power of 6 here. It is 1 by r to the power of 2. It may be useful in the which of the following is correct statement. They will give r 1 by r cube, 1 by r to the power of 6. All are inversely proportional to the radius only, because when you have what happened, large difference between these two, what happened, attraction force will be decreases, right? Next we will see the dipole induced dipole forces. Dipole induced dipole forces, let me take. Dipole induced dipole forces, let me take. Dipole induced dipole forces we can take. Now what is dipole induced means? One is what? Polar, other is what? Non-polar. One is polar. If both are non-polar, dispersion or London forces. If both are polar, dipole-dipole forces. If one is non-polar, other is what? Polar, then that is called dipole induced dipole force. You see here? Polar molecule, non-polar molecule. Now it is permanent. Even though this molecule is not contacting here, this non-polar is not contacting here, the charges are developed here. So permanent. Here we need to induce the force now here, induce the dipole forces now. But induce the dipole now. Now whenever this non-polar molecule is reaching over here, when this non-polar molecule is reaching over here, definitely we are going to arise a positive charge and negative charge. They will develop now. They will induce. Therefore, what happened? Now we got some polars here. Now between these two also attraction forces will operate. And this type of force are calling what? Dipole induced dipole interactions we can call it. So three types we have discussed. One is what? Dispersion or London forces always present in non-polar molecule. Second one, dipole-dipole in polar molecule. Next one, dipole and induced dipole will be what? Polar and non-polar molecules. Then here also if you take the order, it will be what happen? Something like this. 1 by 2 r to the power of 6. Now hydrogen bonding, already we discussed about this one. Just now we'll discuss about the hydrogen bonding. It is always present between what? Highly polar molecules like fluorine, oxygen and nitrogen. Already we discussed this one, HF and everything, right? Understood better? We have discussed 4 type of forces. 4 type of forces we have completed. Any doubts you are having?
No, sir, no doubts.
Now let me see some exercise here. Actually, in this we get a problems only. Boyle's law, Charles problems only we get. Most of the cases what happen, you will get the problems only. And that problem is there in that, I think the exercise it is there, not here. No problem. I'll give later that. Now we'll move to what small topic is there. That we move to what is thermal energy. So that tomorrow onwards we'll discuss about the gases laws, Boyle's law, Charles law. Thermal energy. Thermal energy means what happened when you heat. What happened? Whenever what happened when you heat. Otherwise, what happened when molecules are moving? When you heat, what happened? Some energy is released because of temperature. Okay. So this is generally thermal energy. If you observe what happened, what happens to thermal energy when you compare with what happened? Solid, liquid, and gas molecule, which will have higher thermal energy. Let me see this one here. Intermolecular forces versus thermal interactions. Right. Let me see this one. What? 3 I will take it. Gas, liquid, and solid. Now tell me, in which case molecular interactions are weak and in which case molecular interactions are strong?
So in gas phase,
Solid,
they are
solid
strong.
molecular interactions is strong.
In gas phase, molecular interactions are weak. In solid nature, the molecular interactions are strong. Why? Because in solids, these molecules or atoms are very compressed, that they are exist, isn't it, in the crystal lattice. So they cannot move their mean position. They're having some fixed positions. They cannot move, and they're highly compressed here. So they're having what happened? Strong intermolecular force of attractions. But in gas, what happened? They can move, and they're having space between the gas molecules also very, very less. For example, if you want to draw in terms of gas, what happened? I will draw like this. You observe this one. I'm taking a container here. Okay. So gas molecules we can draw like this, gas molecules. This is the gas molecules. We want to write the liquid molecules. How to write liquid molecules? They looks like this. Like this. This is the liquid. When you write what happens solid here, highly they compress. No, we can write like this. They're highly compressed. You don't have any space between the molecules like this. Like this. So in this case, what happened? Molecular interactions will be strong because they near with each other. Now thermal energy, if you observe what happened, gas will have more thermal energy because they are having kinetic motion, isn't it? Their average kinetic energy, if you observe what happened, which will be what? High, because of what? That momentum, we get what happened? More thermal energy. So thermal energy, in which case thermal energy is more here? Gas phase. And intermolecular forces will be what in? Higher in the solid state. Here, are having higher intermolecular force of attractions here, where gas are having higher thermal energy. Now, this is things generally you have completed in the 8th, 9th, 10th. You got this everything, small information. Now we'll see what happened. This is states of matter. We are discussing about the gases now here, only gases here. Only about the gases here. Now, how many gases are there in the element periodic table? If you observe what happened, if you only take up to 6th period, okay, that means up to radon only, there are 11 elements are there. 11 elements are there. Now, in the hydrogen is a gas. In the 5th A group or 15th group, nitrogen is a gas. In 6th A group or 16th group, oxygen is a gas. In 7th A group, fluorine and the chlorines are the gases molecule. And 18th group, all are what happened? Gases. All are gases. All are gases. So total how many we are having? 11 gases are there. How many liquids we are having? Anybody? How many liquids we are having? Anybody? How many liquids are you having, beta? 2 liquids.
No idea, sir.
Bromine, other is what? Mercury. This is a non-metal liquid. This one is a metal liquid. Non-metal, metal liquids. 2 liquids are there, 11 gases are there. Remaining there what? Solid side. General properties when you observe the gas, because in this total chapter we are discussing about the gases only. Liquid state, solid state we'll discuss in 12th class, right? Now all gas are highly compressible. You can compress gas very easily, right? If you observe this diagram, beta, all of you observe this diagram. Now because of more space now here, you can compress this one by using a piston here. You can compress this one. When you compress, what happens? They come like this. They can come like this when you compress like this. So gases are highly compressible when you compare with what? Liquids and solids, right? They're highly compressible. Gases exert pressure equally in all directions. So when the gas is moving, what happens? It can release more pressure. That is in all direction. The pressure because of bombardment between the molecules or bombardment between the container. When gas molecule, okay, the two gas molecules will bombard, a pressure will be released. Otherwise, when a gas molecule will bombard, collide with what? Container, like this. A molecule colliding with this one. A molecule colliding with the container, or molecules are colliding with each other. The pressure will be released here. Next, gases have much lower density than the solids and the liquid. Why? Because density is what? Is equal to mass by value. So density is inversely proportional to value. Now, if you observe what happened in a container, what is the volume of the gas? Generally, we'll take volume of the container. If anybody asks you, what is the volume of the gas? You take whatever the volume of the gas we can't measure. Gas volume we can't measure actually. So what we can measure, beta? Only we can measure what? The volume of the container. This is the volume of the container only we can measure, right? Okay. So, but gases occupies what happened? Less space in the container, not complete space. But what we are taking, the volume, entire the volume we are taking actually. The mass is what? Less, but volume we are taking more actually. So having what? Less density. They're having what? Very lower density. The volume and shape of the gases are not fixed here. So these assume volume and shape of the container. So if I want what is the volume of the oxygen, so I have to take volume of the container only. This is a very important bit. So volume of the container and shape can taken as the volume of what? Gas and shape of the gas. Gases mix evenly and completely in all proportion without any mechanical aid. For I want to mix this one, nitrogen and hydrogen I want to mix. For this one, I no need to mechanically, no need to operate this one. They do spontaneously, they will mix with each other. Spontaneously, they will mix each other. So no need any mechanical operation for this one. Okay. So these are the some important points about the gases molecule. In examination, this shape is very important. This point is important, isn't it? So this is about the what? Gas. Tomorrow we'll see the gas laws better. What about the gas laws? We'll see tomorrow. Boyle's law, Charles' law, and Avogadro's law. 3 laws we'll discuss tomorrow. And problems are important. In examination, they ask what? Problems only, right? How many are there? Only 51. 9 members were absent today. I will take the attendance beta. All of you stay with me. Abhishek Sharma.
Present, sir.
Abhishek Y. Abhishek Y. Absent. Aditya. Anshu.
Present, sir.
Anuj. Anushka.
Present, sir.
Apurva. Anushka is absent in last two classes. Anushka,
Yes, sir.
you watch the video and make notes because the whatever we discussed in last molecular orbital theory is very, very important. Beta.
Okay,
Watch
sir.
the video and make notes.
Okay,
Apurva,
sir.
Present, sir.
Atul Rawat,
Present, sir.
Adarva, Ayush,
Present, sir.
Balmukund, absent. Balmukund, his name is not there here. Balmukund, absent. Bharati,
Present, sir.
Chaitanya, Deepta absent.
Present,
Deepta
sir.
absent? No, present, okay, okay. Deepta present only.
Present, sir.
Jnaneshwari,
Present, sir.
Gulabi, Kalpesh,
Present, sir.
Krunal,
Present, sir.
Manoj,
Present, sir.
Mayur,
Present, sir.
Ojas,
Present, sir.
Ashif, Ashif absent.
Present, sir.
Ashif, oh, okay. Your name is not there. Kaushal absent. Kaushal absent. Omkar, Omkar
Present, sir. Present, sir.
Omkar PC.
Present, sir.
Dhanasri is absent. Dhanasri.
Present, sir.
Dhanasri. मेरा नाम कहाँ है बेटा यहाँ पर? हैं?
सर ऊपर है.
हाँ, ओके ओके ओके. Pradmesh,
Present, sir.
Rahul,
Present, sir.
Raj,
Present, sir.
Ramya,
Present, sir.
Riya, Rohit,
Present, sir.
Sahil,
Present, sir.
Samiksha,
Present, sir.
Samruddhi,
Present, sir.
Sapna,
Present, sir.
Sardak,
Present, sir.
Shishiranjan,
Present, sir.
Shishidhar,
Present, sir.
Srihari,
Present, sir.
Sonali,
Present, sir.
Sumit, AM,
Present, sir. Present, sir.
Sumit, SD,
Present, sir.
Suraj C, Suraj C absent. Suraj TU also absent. Suraj TU also absent. Triambak, Triambak absent. Umesh, Umesh absent. Vaishnavi N present. Vaishnavi present. Vaman,
Present, sir.
last classes you absent. Why? What is the reason, Vaman?
Sir, there was net problem, sir.
You watch all the videos.
Yes, sir.
Excuse me, sir.
हाँ बोलो बेटा. कौन बोल रहा है
Sir,
बेटा?
you didn't took my name.
वैष्णवी जादव.
Yes.
Yeah, I given attendance. No problem. Vishal,
Present, sir.
Yash,
Present, sir.
Akriti, Akriti absent. Pallavi, Bharti, Pallavi,
Present, sir.
Bharti is okay. Pallavi,
Present, sir.
Swastika. Swastika. Absent. Present. Tejaswini.
Present, sir.
I'm reading the absentee name no better. Akruti absent hai na today. She's there. Akruti absent. Umesh absent. Umesh absent. Triyambak absent. Suraj TU, Suraj C, both are absent. Sneha VS absent. Sneha G also absent. Kaushal absent. Next, Balmukund absent. These are the absentees today. If you have any doubts, you can stay, you can ask me, otherwise you can log out better.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.